All right, lecture 4.3, believe it or not, the last lecture of Unit 4. Can't believe we're already here. So we're going to review some counting methods and see how that ties into some probability applications. And we've already covered one counting method at the very beginning of the unit. It was the first thing we taught. That was the multiplication principle. So here we have a little recap of the multiplication principle, and let's do some practice with it. So first example, a bicycle lock combination consists of 4 numerals. How many lock combinations are possible? So basically you got 4 choices. The first number in the code, the second numeral, the third numeral, and the fourth numeral. And basically each one of these is between 0 and 9, 0 and 9, 0 to 9, 0 to 9. Thus you have 10 choices here, 10 choices there, 10 choices there, 10 choices there. So that equals 10 to the fourth, which is 1, 2, 3, 4, 10,000. So if you're looking at like a standard cable bicycle lock and there's 4 numbers, you basically got 10,000 possible combinations. So let's look at the next example. Each employee is given a username of the form XXYYY, where X is a letter and Y is a numeral. So how many usernames are possible? So we got X is you got a letter, you've got a letter, and then the next 3 you choose between 0 through 9, 0 through 9, 0 through 9. So there's 26 letters in the alphabet, so you have 26 letters to choose from. Now, we can also have another 26 to choose from. If you want to pick the same letter, you can. If you want the first 2 letters of your username to be AA, there's nothing here saying that's not permitted. So repeats are perfectly fine. And then you choose 3 numbers. And each number, well, there's 10 numerals, 0 through 9. And of course, if you want your password to have repeats, you can. If you want not password, but username, if you want your username to be AA333, no, that's possible. So that's basically going to equal 26 squared times 10 cubed. So we're going to go ahead and compute that real quick. So 26 squared times 10 cubed is 676,000. So if the employer wants to go with this username system, they know that there's 676,000 different usernames that are possible. Now, you're looking at these examples, and you may have noticed with the username and the bicycle lock example, it was okay to have repeats. You know, if you wanted your bicycle lock combination to be 7777, you can do that. But what happens if you do not pick any numeral more than once? So what if you have repeats? So, I'm sorry, what if you're not allowed to have repeats? So once you pick a number, you can't pick it again. How many lock combinations are possible? Well, you still got to pick 4 numerals, and we're still using that multiplication principle. So for the first number, we have 10 choices, 0 through 9. Now, once you pick a number, you cannot pick it again. No repeats, because it says here you're not picking any numeral more than once. So if you picked 1 out of the 10, that means there's 9 left. And then once you pick another one, there's only 8 left. And once you pick another one, there's only 7 left. So if you wanted to figure out how many bicycle lock combinations are possible with no repeats and 4 choices, that's going to be 5,040. So if you compare that to the previous example, that almost cuts the number of possibilities in half. So it makes a huge difference when you're not using repeats. And when order matters and repeats are not allowed, we're talking about permutations. So what we just computed in the last example was the number of permutations. So we use permutations whenever all selections come from a single set, no item is selected more than once, and order matters. So basically, all choices come from a single list, no repeats, order matters. And if we want to compute the number of permutations, then that is given by n factorial over n minus r factorial. that's the formula for computing number of permutations. Now, in case you need a little bit of a review, n factorial basically means n times the number just below that times the number just below that times dot 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 3 times 2 times 1. It's basically countdown multiplication. So factorial means you are multiplying in a countdown until you hit 1. So a good example, i.e., 5 factorial equals 5 times 4 times 3 times 2 times 1. So factorial is basically countdown multiplication. And you can see why that's used here. If you look back at the bicycle lock combination, we basically did countdown multiplication. And just a huge note, keep in mind 0 factorial equals 1. So with that formula out of the way, let's go ahead and look at this city council example. So here we got a city council with 10 members. They have an election where they vote for the president first, the vice president second, and the treasurer third. So if you've ever formed in any sort of Greek organization or student body, student government association, you're probably familiar with this process of voting for an executive board. And when you vote for an executive board, you actually do the most important position first. So that's why they're doing the president first. So that way, your most talented people can run for the president, and even if they lose, they can then choose to run for one of the lower positions. Whereas if you do the president last, you might have talented leaders holding out because they're holding out for that president position. But let's go ahead and look here. So we're making all selections from a single list. Repeats are not allowed. Right? You can't have one person who's the president, the vice president, and the treasurer. So you can't pick one person more than once in this problem. So no repeats. Sorry, Jim, you can't be president, vice president, and treasurer. Not possible. And order matters. Because if you vote Jim in first, in the first round, and Sally in the second, that means Jim is president and Sally is vice president. But if Sally wins the first round and Jim wins the second round, then Sally is president and Jim is vice president. In other words, the order matters. So, looking at this problem, you can't have no repeats. Order matters. That tells you we're working with permutations. We're working with permutations. So P for permutations, we have 10 members. We are picking 3 of them for those 3 positions. So now we just use that formula on the last page. That equals 10 factorial over 10 minus 3 factorial. So that's 10 factorial divided by 7 factorial. Most of this is going to cancel out because 10 factorial is 10 times 9 times 8 times 7 times 6 times dot dot dot. 7 factorial is 7 times 6 times dot dot dot. So you can see once we hit the 7, it all cancels, and we're just left with 10 times 9 times 8, which is 720. So there are 720 different outcomes for this election. And you can see that's given by the permutation formula. Now, a quick calculator tip. Your calculator most likely has a permutation button. And for a lot of calculators, it'll look something like this. Something like that. So go ahead, if you need, pause the pencast and look through your calculator and find that permutation button. Almost every modern scientific calculator has this permutation button. And if you can find that button, you can let the calculator do the heavy lifting instead of having to use that permutation formula. So I highly, highly, highly recommend you take a moment, look through your calculator, and find that button. If you cannot find it, just do like a 5-minute Google search. Just Google your calculator model with permutation, and it'll probably tell you where to find that button. So again, I highly recommend you find that permutation feature on your calculator. That being said, let's look at another example. Joe here has got 50 friends on MySpace and must select 8 friends in order of preference. Very important for his top friends list. how many different lists are possible. So, no repeats. Right? I can't pick Frankie, 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 and Frankie. I can't, pick the same person for all 8 slots. It's one person per slot. No repeats. Order matters. Right? If you've ever used MySpace, you know that this is very important. Right? Having Frankie as your number 1 friend and Josh as your number 2 friend is very different from having Josh as your number 1 friend and Frankie as your number 2 friend. If you remember the MySpace days, you remember the agonizing decision of trying to make your best friends list. So, basically, no repeats, order matters. That means we are doing permutations. So, we're doing P for permutations. We are taking 50, choosing 8. So it's 50, choose 8 permutations. Now, if you have a calculator at hand, feel free to pause it and just use your calculator to compute this answer here. Alright, the book typically writes it like this, 50p 8. And that's how you would type it into your calculator. But I'll go ahead and run the formula. So it's basically going to be 50 factorial over 50 minus 8 factorial. So that's 50 factorial over 42 factorial. And let's go ahead and compute that. So we've got math, probability, so 50. Make sure you know how to find that permutation button in your calculator and play with it. And it's a very, very, very large number. So we're going to go ahead and round it. It's 2.1647 times 10 to the 13th power. So that's a huge number. And we get that from the calculator. So this is an example where you definitely want to be familiar with your calculator. Alright, cool. That is permutations. Let's talk about combinations now. So combinations are used in place of permutations and order does not matter. So if we make R selections from a set of n items, the number of possible combinations is n factorial over R factorial times n minus R factorial. And go ahead and take a few moments, find the NCR, which is typically your combination button on your calculator. It will be very useful. Alright, so find the number of combinations button on your calculator, and we're going to go ahead and use that in an example. So we use combinations when we are making all selections from a single list. There are no repeats. You cannot pick the same element multiple times. And order does not matter. So this is a great example of demonstrating combinations. A pizza parlor offers 11 different toppings. How many different 3-topping pizzas are possible? So if we look at this example, we can't pick the same we can't pick the same topping more than once. Right? You can't have a 3-topping pizza that's pepperoni, pepperoni, pepperoni. All right, that's a 1-topping pizza. So the 3 toppings have to be 3 different toppings. And you have to ask yourself, hey, does the order matter here? So if I order a pepperoni mushroom pizza, that's going to be the same thing as a mushroom pepperoni pizza. Notice that the order does not matter here. So if the order does not matter, then you are doing combinations. So basically this problem is no repeats. We can't pick the same topping multiple times, and order does not matter. Doesn't matter. Alright, doesn't matter if I order, a pineapple jalapeno pizza or a jalapeno pineapple pizza. And there's your nightmare fuel for the day. Lord have mercy on your soul if you think a pineapple jalapeno pizza would taste good. But anywho, let's go ahead and finish up this problem. That's combinations, so it's combinations, or uses the letter C, and there's 11, pick 3. Now, at this point, you can just use your calculator. Now, when you're doing this on an example, at least write this part down, so that if you hit the wrong button in your calculator, at least know you had the right idea. But I'm going to go ahead and do it manually since I don't have my calculator here with me. So that'll be 11 factorial over 3 factorial times 11 minus 3 factorial. And let me go ahead and compute that. And you get 165. So, if there's 11 different toppings to choose from, then there's 165 different 3-topping pizzas that are possible. So again, highly, highly recommend. Please make sure you know how to find that on your calculator. All right. Again, if you cannot find it, use Google. All right. Just get on Google, type in your calculator model, you can find it. If you cannot find it, then you can use this formula right there. All right. If you can't find the button on your calculator, you're welcome to use that formula. So let's do one more example, then we'll move on. How many different 5-card hands are possible from a standard deck of cards? So, clearly, no repeats. Alright, each card is unique in a standard deck of cards. You can't get 3 King of Hearts, right? There's only 1 King of Hearts, so there's no repeats. And you gotta ask yourself, does the order matter? Well, it does not matter, because when you get dealt your 5 hands, you're gonna pick them up and you can put them in any order you want. So order does not matter. Right, it doesn't matter what order you're dealt the 5 cards. Right? If I'm dealt a king, then a queen, that's the same thing as if I get dealt a queen, then a king. So order does not matter. That tells us that this is all about combinations. So that's combinations. There's 52 cards. We are picking 5. So it's the number of combinations, 52, pick 5. So let's go ahead and punch that into the calculator. Oops, 52, pick 5. And it's quite a bit. It's 259. 8960. And again, don't just copy me here. If you need, pause the pencast, pull, comma's in the wrong spot. There we are. And you pause the pencast, pull out your calculator, practice this on your own calculator before we move forward. Alright. Let's wrap up today with some examples. So what we're going to do is we're going to go ahead and summarize. So multiplication principle, you're going to use that if you have multiple sets to choose from, or you have a single set where repeats are allowed, then that's going to be multiplication principle. For permutations, that's going to be single set, no repeats, order matters. So if the order of the choices makes a difference, then you're going to use permutations. For combinations, order does not matter. If the order of the selections does not matter, you're going to use combinations. And don't let that word fool you. The word combinations mathematically is different from the word combination used to describe like a locker combination. So let's look at this example. A gym locker combination consists of 3 numbers, 0 through 44. This is just like your old-fashioned gym locker combo, your standard, spin it left, spin it right type dial combination. These are the types of locks you see on like high school lockers, if you remember those. Where you go 3 to the right, 2 to the left, 1 to the right, selecting the 3 numbers as you go. Now, just because it uses the word combination does not mean you're actually using the mathematical combination formula. This one, compute the probability of guessing the combination. So here, repeats are allowed. Right? So here it's possible, your buddy's gym locker combination might be 23, 23, 23. That's a viable combination. So you got to figure out how many possibilities there are. Well, there's 45 choices for the first number, 45 for the second, and 45 for the third number. So there's a lot of possibilities there. There's, 91,125 possible combinations. And we get that from the multiplication principle because repeats are allowed. So that's your probability. You got one guess, and you better hope your one guess is the one of those out of the 91,125. So the probability that you just randomly guess a gem locker combination, pretty low. But suppose you know there's no repeats. So no repeats. So it's no repeats, and order matters here. Because a combination that's 7, 11, 12 is different from a combination that's 11, 12, 7. So order matters here, no repeats this time. So that means we're talking about permutations, 45 pick 3. So if we compute that, again, feel free to use your calculator or the permutation formula. You should be getting 85,140. 85,140. So you can see that's less than what was possible earlier. And it makes a substantial difference. It lowers it down a lot. So if you know there's no repeats, you can drop it down from 91,000 to 85,000, and you better hope your one guess is the one out of 85,140 that are correct. So that's if you know there's no repeats. So last example for this pencast. Suppose you got 16 teams in a local league and 4 teams will go to regional finals. Compute the probability you guess which 4 teams make it to the regional finals. So we got to figure out how many possibilities there are. So first things first, can you have repeats? No. You can't have the same team taking up 4 slots, right? So if you allow me to use an NFL example, you can't have the Patriots, and the Patriots being your 4 teams going into the final. That's not possible. It has to be 4 different teams, so there's no repeats. So that just leaves permutations or combinations. So you got to ask yourself, does the order you pick the teams matter? So if I say the Patriots and the Eagles are going to the finals, is that different from saying the Eagles and the Patriots are going to the finals? Does the order that I choose them matter? Well, no, it doesn't. If I tell you that the Patriots and the Eagles are going to the Super Bowl, that's the same thing as saying the Eagles and the Patriots are going to the Super Bowl. So order does not matter. Order does not matter. If order does not matter, then that's going to be combinations. So it's number of combinations, 16, choose 4. So since order does not matter, it'll be combinations, and we can compute that, and we get 1,820. So there's 1,820 different possibilities here. You are only guessing one of them. So the probability of you randomly guessing which 4 teams make it to the finals out of the 16 is quite slim. This is almost kind of tied to the mathematics of March Madness. If you go back to the March Madness and trying to guess a perfect bracket, the mathematical probability of you randomly guessing the outcomes is damn near impossible, which is why the prize is so large. But anywho, we are done with Unit 4. So guys, please make sure to finish up that test review and make sure you are ready for the exam, and keep up the hard work and have a wonderful day.